Hey guys, welcome to the channel. My name is Zen, and I've been helping students in their academic pursuits for the past 4 years now. I've since started making videos to further help students learn their physics and chemistry in the shortest way possible. If you do like these videos, do consider giving me a big fat thumbs up and subscribing to the channel for more videos like this. So without further ado, let's jump straight into the topic. Okay, so now we're going to do forces, okay, otherwise known as dynamics. So you need an A4 paper, right? Split it into 4 again. 1, 2, 3, 4. Okay, so this one, fundamentally, I'm not going to go through Newton's first law, second law, and third law again. I will be focusing more on the question types and how to solve the different questions, right? The content-wise, I'm pretty sure you guys already have the notes on it, onto like what's the law and where to memorize it. And so you all just focus on that, okay? But now I'm going to teach you guys on how to tackle different types of questions. Okay, so the very first question type we're going to do is in part 1. So whatever I'm going to write now is in part 1, okay? So the very first type of question I'm going to go through is known as the scenario question. This question type has always been a hot favorite among O-level setters, okay, either in MCQ or in structured question itself, okay? So very high chance that this is going to come out, okay? Even if it doesn't come out, it provides a lot of learning opportunities for us to take away from the question itself. So first one, okay, you can afford to write it a little bit long, write your working a little bit longer. I don't have any, there's only one question here, one example question here in the scenario question itself, so it's fine. Okay, so when a force of 4 newtons is applied to a wooden block, okay, of mass 2 kg, the block moves with constant velocity. If now the forward force is increased to 10 newtons, what is the acceleration? Okay, these kind of questions has a lot to unravel, in the sense that there are important information, important phrases in the question. Now, for those who have been with me for quite a long period of time, you will know that every time I see this phrase, constant speed or constant velocity, I will always want to write something above it. Okay, and this is known as acceleration equals to 0 meter per second squared. Okay, always give yourself, give your eyes, give your brain an easier time by writing all this important information out first. Okay, so in the first scenario, right, why do I call this in a scenario question? Because in the first scenario, they tell you that it's moving at constant velocity, and then the next scenario, they ask you what is the acceleration. Take note, it is the same block. It is the same block. So we have a 2 kg block, we have a 4 Newton force, and I know my acceleration is 0 meter per second squared. What does that tell me? That means my resultant force, okay, is 0 Newton because of the 0 acceleration. And this doesn't add up. There's only a 4 Newton force. How can the resultant force be 0? Which means there is a frictional force of 4 newtons. Okay, this is what the scenario question. The first scenario is for you to infer and figure out what the frictional force is. And this frictional force is 4 newtons. Okay, now we bring this into the next scenario. 2 kg force. I'm going to increase my this thing to 10 newton. Friction remains the same. Okay, no matter what, friction remains the same. So therefore, this is 4 newtons as well, right? So my resultant force is 10 newtons minus 4 newtons is equivalent to 6 newtons. Zen, but they're not finding resultant force, they're finding acceleration. So how do I do that? Very easy. So 6 newtons equals to 2 kg times A, and A would therefore be 3 meter per second squared. Okay, this is called a scenario question. The first scenario is for you to figure something out so that you can apply it into the second scenario and to solve the question eventually. This is a very famous, very popular question type. Okay, so copy this down, right? And we'll move on to the next question type. So after that, we move on to the next question type. Okay, and that is called segmentation questions. Okay, segmentation questions. Take note that this column will be split into two. Okay, will be split into two. Right, so that's kind of like a 2A, 2B kind of a thing. So if we take a look at segmentation questions, we have C. Okay, so the first step here is to isolate the body. Okay, isolate the body basically just means that A will have a free body diagram, B will have a free body diagram, and C will have a free body diagram. So I'm going to guide you guys on how to draw this free body diagram. Okay, it doesn't matter what object you are drawing. It can all be represented with a rectangle itself. So we have A with a forward force, and then there's a tension holding him back. So this tension, right, is this rope here. I'm going to circle it for you all. Is this rope here. Okay, this rope. So this rope, I can call it tension A. But please take note on what you call it, because this will play a very important role on how you draw free body diagram B. So if you draw it for B, because you called it tension A at the start, the thing that is pulling it forward will be tension A. Is that why there? Not tension B, man. Why? Why both tension A? Because it is the same rope. It is the same rope. You cannot go and give it a different name. Then you realize you got too many unknowns and you cannot solve. Okay, so likewise, what is going to happen? The backward force will now be known as tension B. And then after that, for C, we have a forward force, and this will be tension B. Hey Zen, how come got two tension B again? You don't make sense there, because we are looking at this rope. It is the same rope. Okay, so this one, if I call it tension A, this will be tension B. Okay, now that is step one. Then what do I do with the next step? Okay, step two. Okay, use Newton's second law. Okay, now N2L is basically Newton's second law. Get used to this short form. Okay, so for the very first one, for part A, how am I going to form it? Okay, front minus back equals to mass of A times acceleration. That's for A. Then for B will be TA minus TB equals to MB times A. And then for C, right? For C, we have TB equals to MC times A. Then they all belong to the same system. Does that mean they have the same acceleration? The answer is yes. Okay, as long as you belong into the same body, right? Same system, the acceleration is the same. Then can you give me a real life example of how this works? Okay, very simple. If you are taking a bus, okay, if you are taking a bus, you're sitting in the bus. If the bus is moving at 50 meters per second, you are also moving at 50 meters per second. If the bus is accelerating at 50 meters per second square, you are also accelerating at 50 meters per second square. Your motion is tied to the body you are linked to. Okay, same thing happens for cars, same thing happens for MRTs, same thing. That's why when the train suddenly jam brake, okay, or emergency stop, you fly, right? Due to the whole concept of inertia. Okay, but that topic on inertia, I will talk about it later. Okay, so this is a segmentation question. And then we move on to the next part of the column. Okay, still the same column, still a little bit of the segmentation question, but this one I'm going to call it pulley, still part two. So this is called a pulley system. Okay, a pulley system. What's a pulley system? Right, we have like a 4 kg here, 2 kg here. Now, pulley systems are very unique because it's circular in shape. Okay, for the previous question, right, we can choose left to be positive and right to be negative. But for the pulley system, you need to choose a direction, like a clock, right? So either you choose clockwise to be positive or anti-clockwise to be positive. But in this case, I know the pulley system will move in direction of the heavier object. So I will definitely choose clockwise to be positive. Okay, I'll definitely choose clockwise to be positive. Zen, what do you mean by clockwise and anti-clockwise? I can't do this. Okay, relax. After choosing the direction, step one, what we're going to do here is to isolate the body again. So for the 4 kg, we have a 40 Newton force downwards, and then we have a tension upwards. Anytime you see a shrink, there's always tension. Okay, always got tension. Then what do we have? We have the 2 kg one, we have tension upwards, and then we have 20 Newton downwards. Okay, very simple. Now, step 2. Okay, use Newton's second law. Because the 40 Newtons is in a clockwise direction, it's pointing downwards in the clockwise direction, so he is positive. Okay, so I'll take 40 Newtons minus T equals to 4 kg times A. Okay, that's for the 4 kg. Now we take a look at the other body. Which one is going in the clockwise direction? 20 Newtons of tension. The tension is down here, is pointing in the clockwise direction. It's pointing in the clockwise direction. What does that mean? Which means tension will be positive, minus 20 Newtons equals to 2 kg times A. We have that step 3, solve using. Okay, solve using substitution. Very simple, right? 40 Newtons minus T equals to 4A. T minus 20 Newtons equals to 2A. Then you sub into one another, cancel off the unknowns, and solve the question. Okay, this is the pulley system. Okay, I'll move on to the next column. The next column, I will call this the link to kinematics. Okay, the link to kinematics here is going to be pretty interesting because it's going to mix or combine the concepts of both dynamics and kinematics into one question type itself. Okay, so for instance, they give you this. Okay, they give you a speed time graph. Okay, they give you a speed time graph, right? And then they ask you to interpret the graph first. Okay, they give you a speed time graph and then they ask you to interpret the graph. So the very first step is to determine the gradient. Okay, and we know that this is a constant gradient. Okay, this is a constant gradient. Now, what would they ask? Then they will ask you what kind of force is being applied. Okay, what kind of force? Okay, so you have Fr equals to ma. Mass is definitely a constant. Acceleration is also a constant. Why? Because you interpreted it from the graph. Therefore, the question will ask you what kind of force is being applied. Therefore, you can safely say this is a constant force is applied. Okay, so for one, how do I determine what's the acceleration? Okay, I take a look at the speed time graph. If it's a constant gradient, that means it's a constant force is being applied. Okay, this is not all for column number 3. There's another part to it. Okay, so this is the forces linked to kinematics. The next part, still the same column, is how we are going to use it qualitatively. That means how we're going to calculate certain things. Okay, so for example, they can give us, this is the link to force. forces. So we can have a graph that looks something like this. Let's just say this is 14 newtons. This is a force Newton. This is a time per second graph. And this is 0 Newton. So the graph basically looks like this. It goes like that, and it goes like that. Okay? And then the timing here will be 4 seconds and 6 seconds. The mass here that we're going to talk about is 2 kg. Okay? And then let's just say there's a frictional force of 2 newtons. Right? So at this point in time, we need to determine, right, what is the final velocity, perhaps. Right? So first thing first, from this information, let's determine the acceleration first. Let's determine what's the acceleration. Because we got resultant force, no, we got the applied force, we got the frictional force, we can find the acceleration. So let's segment this into part 1 and part 2. So in part 1, Fr equals to ma. So I have 14 newtons minus 2 newtons equals to 2 kg times A. Okay, so I will have 12 newtons equals to 2 kg times A. A equals to 6 meters per second squared. That's part 1. How about part 2? For part 2, I got 0 newtons as an applied force, but I still have a frictional force. Just because I have no more applied force doesn't mean the object is at rest. Just because I don't have an applied force doesn't mean the object is at rest. So 0 newtons minus 2 newtons equals to 2 kg times A. And I will find out that my A is minus 1 meter per second squared. Okay? I will know that my acceleration is minus 1 meter per second squared. Now, we need to find out what's the final velocity. Okay, so determining final velocity. How do I do this? Very simple. We sketch the graph. Sketch a velocity time graph. So velocity meter second minus 1 time per second. Right? How long did the object accelerate at 6 meters per second square for? 6 meters per second square for 4 seconds. Okay? 6 meters per second square. Why do I put a 6 there? Because that's the acceleration. That's the gradient. And then after that, for the next 2 seconds, he decelerated. Minus 1. Okay? How do I solve this? If every second I increase my speed by 6 for 4 seconds, my maximum speed is 24. You check. 24 divided by 4, does it give me 6? Yes. My highest speed, okay, is 24 meters per second. What is my final speed? If every second after that I minus 1 meter per second for 2 seconds, my final velocity will be 22 meters per second. Okay, so questions can throw you a curveball like this. Okay, really stretching your concepts of both forces and kinematics and then putting them together. So I repeat what we have learned here. Okay, we learned that the applied force can be introduced in a graph. We know the frictional force, and therefore we can solve for the accelerations for both parts, part 1 and part 2. What can I do with that information? I can put it in a velocity time graph. Then where do you get the values of 4 seconds and 6 seconds? Well, if you take a look, 4, 6, 4, 6. I'm just following the graph. Okay, in the first 4 seconds, the acceleration is at 6 meters per second square. In the next 2 seconds, right, the acceleration is at a minus 1 meter per second square. So therefore, you can actually solve for the velocity right at the start, right at the highest point, and at the end of the motion, which is you get 24 and 22. Okay, now we move on to the next part where we are going to do a little bit of vector diagram drawing. Okay, vector diagram drawing. Okay, this is column number 4. Vector. Okay, vector diagram drawing. Okay, this one very simple. I know you all got a very iffy, don't know how to do this. Okay, so step 1 is the system in equilibrium. Yes or no? Okay, is the system in equilibrium? Ask yourself that. Then what is equilibrium? Equilibrium means the system is not moving. That means it's just hanging there. It's just hanging there. It's not moving. Okay, it's not being capsized. It's not like dropping down. It's not anything. Okay, so equilibrium just means it is not moving. Okay, not moving. So there's only 2 possible answers for this. Yes and no. For both of them, they lead to step 2, which is to design a scale. Okay, what does design a scale mean? Example, let 1 cm represent 5 newtons. Okay, then after that, we move on to the next part, okay, which is the drawing. So the next part is to draw the vector diagram. Okay, so for the yes part, which we draw the vector diagram, so I'm doing it for the yes, I'm doing it for the no. Okay, for the yes part, right, it's very simple. Very simple. Okay, the yes usually means everything is very nice. What do I mean by nice? It means that if I have an arrow here, I have an arrow here, I have an arrow here. Okay, this is called in equilibrium. Okay, let's just call this weight, let's call this tension, let's call this force. 3 random forces. Okay, all arrows point in the same direction. Okay, that's equilibrium. All the arrows will point in the same direction. Okay, give me an example of something in equilibrium. A pendulum bob that is not swinging, it's just staying there. That's called equilibrium. If it's a pendulum that is moving, that is not in equilibrium. It is moving. There's a net force. Okay, there's a net force. So in this case, for not in equilibrium, how am I going to do this? I will draw the weight, usually, and maybe a tension. Now, the forces must not point in the same direction because this is a resultant force. Resultant force means the forces cannot point in the same direction, which means if you close this up, right, you feel like you should do this, but this is not the correct way because it closes it up and everything is pointing in the same direction. So therefore, you will point the arrows in the other way and label it resultant force. Basically, the resultant force must point in the opposite direction. But then, my teacher tell me, draw parallelogram method better. Okay, fair enough. I'm going to teach you how to do the parallelogram method. You draw one force down, you draw the tension here. What you need to do is to complete the parallelogram. Okay, you completed the parallelogram. You will realize that the resultant force is still the same. It goes like that. Then how do I know where to connect my resultant force? Doesn't make sense. Okay, watch. The point in which the resultant force will originate from is always the point where there are 2 arrows coming out of it. Can you see? It's always the point where there are 2 arrows coming out of it. That is the origin of the resultant force. And we will point to the opposite end. Okay? So let's take a look. Take a look. This has to be an example for equilibrium. Okay? So same thing, I will draw a weight down. I'll draw a force here. And then I'll draw a tension here. Okay, they all point in the same direction. So I know that this is in equilibrium. Okay? Then how do I know where I can put the different things? Okay, so I will draw one down. Right, I always start with weight. Then I want to do like a jigsaw puzzle. What can I put next? I put force here. And then after that, I will do this. tension because tension is pointing in this way, right? So I can actually have a rough sketch of it on the diagram itself. Okay, so this is the example that is in equilibrium. Okay, now let me give you another example. Okay, let me give you another example. So let's just say there's a ball, there's a weight here, and there's a force that is pushing it to the side. Okay, right? So this one here, how do I know where to draw my resultant force? Very simple. Once again, I draw my force, I draw my weight. I must complete the rectangle or complete the parallelogram depending on what the question gives me. This is a very simple setup. So I will complete, right? My resultant force always originates from one point, the point in which two arrows come out, and it goes to the other end. This is your resultant force. Okay, it comes out from one point in which two arrows come out. How do I see that? This and this. Okay, and it goes to the other end, and that's my resultant force. Okay, so this is whatever it is for forces. Hey guys, thank you for watching all the way to the end of that video. I hope it has benefited you in some way. So if you really like videos like this, please subscribe to the channel and I'll be sure to upload more content like this to keep you guys going. I'll see you guys in the next video. Bye.